As we learnt when discussing departure procedures, approach procedure design is similarly dictated by the terrain surrounding the aerodrome. It is also dictated by the type of air operations being undertaken and the type of aeroplanes flying there. All of these factors will influence the sighting of and the type of navigation aid that supports the approach procedure to the runway in use. Speed is also an important consideration, as you will recall from the departure procedure process. The critical speed is the speed at which the aeroplane crosses the threshold of the runway, VAT, but other speeds have important implications. The table shown here relates speed to category of aircraft, to allow you to determine the correct speed for your instrument approach. There are two types of instrument procedure, and they are defined by the type of guidance that is provided to them. These are the straight-in runway approach and the circling aerodrome approach. The type of approach is based upon the sighting of the navigation aids, either at the aerodrome, as is the case with the straight-in approach, or away from the aerodrome, as is generally the case for the circling approach. These approaches can be further subdivided into precision and non-precision approaches, to which we will now turn our attention. A precision approach gives accurate track guidance during the final approach phase and information concerning height above the threshold of the runway. In precision approaches, external equipment is required for it to function, but by accurately flying the required track and glide path, the aeroplane is kept within the protected area, ensuring terrain clearance throughout the procedure. For a precision approach, a pilot is required to calculate the point on the approach that he must either make a decision to land or go around. This is called the decision height or decision altitude. Notice the figures in the right-hand column, headed VMC, OCA. The VM stands for visual manoeuvring, and the C for circling. These are the figures, therefore, if you want to use this approach, not as a straight-in for runway 08, but to circle the aerodrome for a different runway, the circling approach. If a precision approach is flown correctly, when a pilot reaches his decision height, the aircraft will be safely at the place it should be, just as if visibility was perfect. From this point in the approach, the landing will be continued to touchdown visually. This portion of the approach is not VFR, it is completing the IFR procedure visually. Except where blind landing equipment is fitted, a precision approach will lead to a visual final approach and touchdown. To accomplish this, a minimum RVR and visible runway centerline is required. The use of increasingly accurate technology, specifically ILS and FMS systems, has meant that this visual element to the precision approach is being reduced to its minimum. ILS systems are categorized by accuracy of operation, and this results in a specified decision height or altitude and minimum RVR requirements. Both ICAO and JAR have their own defined systems, but we will teach the universal ICAO requirements. You can see from the illustration the differing categories applied to decision heights. You must also remember that once you have commenced an instrument approach procedure, you must complete it as published, unless given contrary instructions by ATC. Even if you complete the approach visually, the requirements of the procedure must be complied with. Where no ground equipment that can provide height data to the aeroplane exists, the procedure is defined as non-precision, although the track guidance may well utilize devices that would serve a precision approach as well. Non-precision approaches are normally provided with track guidance from VOR or NDB equipment, but might utilize the track guidance data from ILS localizers or PAR azimuth equipment. Another type of non-precision approach is the surveillance radar approach, SRA. This is a non-precision approach, usually to a runway, whereby the air traffic controller provides azimuth and distance information, along with suggested altitudes, to maintain a 3-degree glide path. This approach often terminates at 2 nautical miles from the runway threshold, where the pilot will either continue for a visual landing or go around. Sometimes an SRA terminates with a circling manoeuvre, complying with the defined visual criteria, to land in a direction other than that of a straight-in approach. This is called a visual manoeuvre, and we will explain it further later on. You must not continue an instrument approach beyond the outer marker fix in the case of a precision approach, or below 1,000 feet above the aerodrome in the case of a non-precision approach, unless the reported visibility or controlling RVR is above the specified minimum. If, after passing the outer marker fix on a precision approach, or descending below 1,000 feet on a non-precision approach, the RVR falls below the specified minima, the approach may be continued to DH or A, or MDA or H, but you must not continue beyond a point which the limits of the operating minima specified for that aerodrome would be infringed.